Hi everyone, how are you? Yeah, probably let's get started. Before we start, who like cakes? Yeah, and who like monads? Great. So today we'll talk about cakes and monads. Yeah, it's me. I'm Scala developer at Anderson. So I'm responsible for development, architecture, deployment. Also, I'm participating into Kyiv Polytechnic Institute open source community. It's a Trimbita project, Cakeless. The third one is it's not necessary. For instance, Trimbita consists of about 500,000 of lines of code. So yeah, it's hard work, and we are working on it. So let's talk about dependency injection in Scala. First, it is runtime DI from Java. Spring, Juice. From FP Vault, it's reader monad, or for the old one, it's Clysely. We also have compile time DI, like Macwire, and we can just inject into constructor without DI. So, and the problem is what to choose. Yeah, it may be a bit difficult. Every approach has its own pros and cons. Who's familiar with cake pattern? Yeah, probably most of us. In few words, the main idea behind the cake pattern is to define some components with unimplemented members, and then define some functionality. For instance, yeah, it's next slide. In this slide, we just need to keep in mind that execution context component provides execution context. This is some kind of configuration and properties. Then, for instance, using Scala self-typing mechanism, we can define other traits depending on some components, and then define some implemented functionality. For instance, we can asynchronously get configuration using implicit execution context from the execution context component and file configuration path. We define a lot of such components, stack them, and in the end of the program, we just instantiate them. The good parts of the cake pattern: it's easy to test because we can provide component implementation with mocks. Mockito works very well with cake pattern. It is easy to compose because we just mix in different components. And it's also easy to develop because when you need some kind of dependency, you just frequently write actor materializer component. IDE recognizes what you mean and automatically imports it. But in large projects, wiring is very huge. Yeah, it's just an example from one of my projects. Currently, I'm developing online bank, and it's just a sample of the main method. 2,000 lines of code of lazy val something equals this, and about 15 of these clauses. Yeah, it's very painful. And unlike Spring or GIS, it doesn't allow to provide lifecycle management for components. For instance, singleton component, it's when it's lazy val, not dev. But you are not allowed to retry, you are not allowed to provide some fallback components. You should do this by your hands. What about FP? Yeah, we'll talk about reader monads. Actually, reader monad is just an abstraction over functional composition. In this simple case, we have some dependency called email server. Probably is something to send emails. Having some method returning future users. We can map over it, do some stuff. Actually, the main idea is that email sender is actually the dependency that we actually define in components in cakes or in the constructor using geese or spring, so that we can perform some computations, abstraction over the dependency we have, and provide it using run method, just passing it as a function parameter. Yeah, reader monad is easy to test also because it's pure functional, it's pure functions, it's very straightforward, it's pure, and thanks to cats, it provides error handling. For instance, yeah, reader is the simplest case. Actually, there is a reader T, reader transformer, when you can provide some monad for error handling. For instance, future, either, try, or IO. So yeah, having error handling, we can perform lifecycle management. But it's hard to compose because reader monad flatMap is very stupid. Reader doesn't allow you to compose your dependencies because if you look at this slide, this dependency type is fixed. Flatmap signature doesn't allow to provide reader with different dependency type. So yeah, it's a bit hard to compose them. Macwire, it's compile time dependency injection. It automatically generates code. It automatically lookups for dependency in the scopes, in the filters. Scala compiler provides implicit resolution, and it enforces you to tag, because if your classes depends on some very common types like strings, integers, Macwire looks at the scope, it sees two integers, say, I want to inject because there's two integers. And tagging forces us to describe our program more verbose. For instance, you will not have just a string, you will have string tagged as username, for instance. Yeah, so it looks bad not. But how many people used Macwire? How often you got null pointer exception? I think first time you tried Macwire, you got null pointer exception, because when you use Macwire in traits, you should define value as lazy vols. Also, about not obvious, I can just give you an example. In our banking system, we had production environment, no, production main and demo main. And somebody messed up, did wrong import, and he imported production database access object into demo version. So yeah, it may be not obvious as it looks like. Scala developers not like runtime DIM because it's runtime exceptions. Often you can define some functionality, deploy or try to test, and you got runtime exception because you haven't defined the method to provide some dependencies. Yeah, so forget about runtime dependency injection. So why not to combine all these approaches? I mean the positive things. We can create new monad that will be easy to test, easy to compose, easy to develop, with error handling, with without boilerplate, possibly purely functional, and with lifecycle management. But we have two chairs. Cats effect and ZIO. What about cats effect and cats? It allows us to stack monads. We can have writer T, either T in writer T, IO into either T into writer T, and so on. And it may be very useful. It also easy to integrate, even with ZIO. So you can use unexceptional IO from cats, Monix, and other implementations. On the other hand, ZIO provides clarity because it has less dependencies. So when writing flatMap, you using cats, when you write flatMap, you see, yeah, it requires some flatMap type class, or oh, this requires applicative functor. It's a bit hard. Zio doesn't have such dependencies, so it's more clear and more user-friendly. It provides effect systems. Why effect system is better? Let's imagine you have a trait with an implemented member returning pure I/O without effects. Developer implementing this trait, he is not allowed to perform some effects like printing into console, taking random numbers, scheduling something, and so on. It just won't compile unless Java developer comes and writes existence of. Unfortunately, but it's better. Yeah, and it's zero dependency. So why not both? Actually, let's talk about Cakeless, which has both cats and ZIO implementations. The core concept is that Cakeless is implemented using macros, and it's like shapeless at Macwire pickups the dependency type, lookups for the dependent values. So it's actually a monad having a dependent dependency type. It's like representation in shapeless.Generic. It has smart flatMap, unlike a reader monad, allowing you to combine dependencies. I'll show you in examples later what it means. Actually, it provides monad and comonad functionality, error handling using recover with, resource management using brackets. It also provides automatic and semi-automatic dependency injection. Semi-automatic is like passing dependencies into run method in reader monad, and automatic it's like Macwire does, but macros. So let's start with creating a cake. I've made type aliases for simplicity, to simplify it. Let's imagine we have some component. Yeah, I showed you it before. One component and the second one. Yeah, I've added some type annotations for clarity. Actually, it's the cats-based implementation. So, yeah, it's very easy to understand, because just cake delight means that it calls IO delay. So it suspends side effects. The type signature tells us that this cake monad runs on top of IO monad. It actually instantiates component 1, and its dependency type is the following HList. Special macro picks them up at compile time, so that you can then combine the dependencies in flatMap. Actually, what means smart flatMap? If you see at the type signatures, the first cake depends on execution context, some configuration path. The second cake also depends on execution context, on some properties. And then, if we'll combine them in for comprehension, so that we are using flatMap, using shapeless union, we can accumulate the dependency type, unlike reader monad does. So if cake1 depends on execution context and cake2 also depends on execution context, we don't want repetitions. So the resulting program depends on execution context, on configuration path, on properties, because they're unique, and it's all. Is it clear? Okay. The second point is that, yeah, as you see, by default, dependencies are HLists. using as method, you can cast the dependency into a case class. And then using bake method, you can provide the dependencies. For instance, execution context, configuration path, tag it, properties, and some token. It doesn't matter. And at the result, you will have, in this case, IO monad of string, because the resulting type of this cake is just string. Okay. Additionally, Cakeless provides automatic varying. What it means? It's like Macwire does. For instance, yeah, having the same cakes, the same program, and actually the dependency type. Oh, fuck. Tick. Yeah. Having some dependencies in the scope. In this case, it's probably in some object in the local scope at execution context as implicit value, global execution context. Calling auto method, you will have the cake automatically baked. Yeah, it does the same as Macwire. So actually, if you don't care about composition, you can just write cake the type dot auto, and you will have your component baked. Unfortunately, Macwire works well only with plain classes, and it only lookups in the constructors, apply method, and so on. Unlike Cakeless, which lookups both into the constructor and into the unimplemented methods in the components in the cake. Is it clear? So this one is cats-based implementation. Cakeless also has zero implementation. In this case, the monad is called CakeZ. What does it provide? Component type, dependency type, effect type, and exception type. So in most cases, it follows the zero functionality so that you can bake the cake. Mapm, it's like flatMap, so put str ln is 0 with console effect, and you can map errors. So in this case, CakeZ originally has no effects, throwable as an error, but after mapm, it has console effect, and then it has a string error type, because we mapped the error. Additionally, yeah, Cake1 has no effects, Cake2 has console effect. Combining them into flatMap, we also combine the effects along with the dependencies. Is it clear? Okay. Both ZIO and cats implementations allows you to make your cake a singleton one. It's implemented using ref, cats.effect.ref or ZIO ref. Cakeless provides, for instance, postStart use f. It's it's a higher order function allowing you to perform monadic transformation on the created component. For instance, in this case, if you look at the cake signature, we have that database component. So it is a bad idea to open database connection when creating instance of the class. It must be done explicitly. So postStart use f allows you to, for instance, open database connection and even do some retries. Plain retries, linear, exponential. Additionally, you can catch exceptions and handle them. In this case, it just failed with println, but you can do something more meaningful. Additionally, both implementation provides bracket method. Who doesn't know what means bracket? Bracket, it's like try finally, but on monods. In this case, relays will be executed whatever use block succeed or fail. It's like finally case. And additionally, yeah, probably I need to show some code for better understanding. Few seconds, please. Does everybody see it? So if you look at nested component, it actually depends on some traits, and it has a constructor parameter called token. Additionally, it provides two constructors. First one takes two strings, and the second one takes just a number. So we have three different constructors and three different dependency types. So Cakeless allows you to choose the appropriate constructor if some exists. If you, for instance, by default it takes the primary constructor, it's number 0. If you'll pass number 1, it will take the second constructor with username and password. When you pass 2, it will pick up the constructor and its dependency type with integer. If you pass 3, it won't compile. Or if you won't pass literal integer, it also won't compile. It is some kind of dependent type implemented using macros. Yeah, and it's demo time. So let's vote. I have both cats and the IO implementations. Which one to show? Okay. So back to idea. Where is the mouse? Let's start with basic one. Let's enter presentation mode. Where is it? Maybe somebody remember shortcut? Yeah, thank you. Yes, so in this case, we have some cake1. Logit just prints this message exactly after the cake instantiation in for comprehension. Component 1 is this type. Then we can create the second one, the third cake, and then we can perform some useful computations. Let's get asynchronously config file. Let's look up for some property, and let's look up in the configuration file for some key, and return. Yeah, value is optional, so we can perform some computations upon option. So as you can see in this example, we can actually define a pure function performing our computations and depending on those components. And on the top of the program, or in some other place when you actually need those components, we can just combine them in for comprehension. Then, having this program, we can provide all the dependencies by hands or automatically on the top of the program. Keeping dependency injection, it's just a few lines of code. It's much less than cake pattern. And then work with this result. So maybe somebody have questions about this example? Yeah, probably it's clear. Let's run it. Yeah. I have this play button. And yeah, it works. With none, but works. Probably I haven't added configuration file, but it doesn't matter. Let's look at compile time wiring. Auto sample, the 0 one. Actually, the example looks very similar, but in this case, yeah, we also create cakes, combine them, perform some computations, but at the end of the program, we just call auto method. What auto method does? It lookups for configuration path. In the global scope, in the local scope, it lookups for properties. Additionally, it depends on execution context, which is imported. And it works fine. Yeah, in this case, I've added property file, so it works fine. What will happen if you don't have this dependency in the scope? And it won't compile. Yeah. Probably it's because of white box macros. Actually, there must be error message, better error message. Let's also provide configuration path 2 times. And it also won't compile. In this case, it will work. Does it look clear? Okay. And probably the last example is about Lifecycle. Actually, the example is the same. Yeah, we can perform some action before start, after start, use the component after start, catch errors, use brackets. Yeah, this is because of this kind of tagging. Singleton operations from Shapeless. It's for one who use Vim and it doesn't care about IntelliJ. So the main tweak is in the database component, because the database implementation, it may sometimes fail. So after running the example, you will see that in some cases it runs immediately, in some cases with some retries, but it works. As you can see, preStart, started, opening connection again, open it connection, close it connection with the database. When we run it again, you can see more open connections, it's because of more retries. Yeah, having retry and schedule policy, we can easily manage the resources. Is it clear? Okay, actually, it's all about the examples. If somebody is interested, I can talk about macros, show you some implementation details. Okay. First, yeah, who used macros in production or for implementing libraries? Not much people, yeah. Yeah, I use macros frequently, and the good thing I found, there are macro utils library providing some useful stuff like warnings, failures, looking up concrete type, looking up silt trait families, and primary constructors parameters. So if somebody will decide to use macros, I'll recommend to look up for macro utils. Yeah, probably I'll start with the kernel, because both ZIO and cats.Effect implementations share the same kernel. So yeah, I have some CakeT base with F with whole and A. It just has the dependent type and the bake method, unimplemented one. And auto is just it's just using this implicitly derived type class. So the main caveat is how to keep shared code for such different implementations. Going back to the class I've named dependency resolver, as you can see, it uses white box macros. What is the main dependency between white box and black box macros? Black box is actually the resulting type of the black box macros is the same as it declares. White box macro instead. For instance, if your macro function returns an instance of the trait, black box macros will return exactly the same type. White box macros will return more concrete type. For instance, it may return database component with something else, and IntelliJ won't figure out, but you can easily call the methods from something else, it will work. White box macro is used by shapeless for generic, for HList. In this case, I use white box macros for picking up the dependency type. And actually, the algorithm is a bit tricky with recursion, but it works fine. The kernel provides you a way to pick up the dependencies at the compile time. The only thing is left to do is to instantiate the cake. For instance, I have ZIO resolver, and what it does is just those few line of codes. Sorry for unsafe run, but I should did it. Yeah, it's how quasi-quote looks like. You pass code as strings. This interpolation is used to provide concrete types. As you can see, A is a type. Base cake is some piece of Scala abstract tree. I can pass arbitrary code, do imports, and so on. And the Scala compiler will check it. And if it is correct, it will compile and work successfully. Also, I have auto-backing implementation. It's like Macwire does. Yeah, some pieces of strange code, but it just lookups the scope, the global scope, the local scope, type checks the errors, and it's fine. Yeah, probably it's all. Probably somebody have some questions about macros, Cakeless, monads. I'm open for any question. Yeah?
Hi, thank you for the talk. Does your library provide a feature of observing the graph of the dependencies? Or if not, can we implement it somehow?
Dependency graph. No, it doesn't support it, but
Do you think
actually I don't see a need for it because by default it cannot have cyclic dependencies. So exploring the graph, probably some optimizations, but yeah, probably we can implement it at compile time if needed. Its library is very young, so currently not.
Okay, thank you.
Somebody else? Yeah, thank you for your all. See you again.